Hello. In this week's report, we transmitted an audio signal through an infrared beam using op amps. Over here, we have our audio input. Our audio input is stereo, two signals, but we converted that to mono by connecting these two here. Red as the left channel, white as the right channel, and black as the ground. Through this divider. This capacitor helped smooth out the signal. And this plus 5 volts and divider here added a DC offset to our signal to better compare with our oscillator. Our oscillator circuit used this plus 5 DC volts through a divider and then into this op amp. This op amp with positive and negative feedback provides an oscillating signal of the power supply voltage, not shown, of plus and minus 5 volts, oscillating back and forth. And then through this capacitor, through this low-pass filter, it helps smooth out the signal. Into this comparator, we fed this oscillator and the audio signal. This comparator converted this analog signal into a digital one transmitted by the LED. The output of the oscillator, of the comparator, is equal to the input, the non-inverting input, minus the inverting input here. The total of the power supply voltage, not shown. This output will then be a digital signal of plus and minus 5 volts, the power supply voltage, through this LED to transmit the infrared signal. Here is the circuit used to take the LED signal, infrared signal, convert it back into analog, and play it through the speaker. We used a phototransistor here, like a normal transistor, that takes the infrared signal from the LED as a basic gate voltage. That would divide this plus 5 volt signal. Then through the capacitor to smooth it out, and then adding our DC offset again. That goes into the inverting input of our comparator. On this side of our comparator, in the non-inverting input, we have another plus 5 volts signal divided down through a potentiometer at R16 to whatever voltage, reference voltage, is needed to get the best quality. This comparator helps turn the digital signal back into more of an analog signal, audio signal. Then through this low-pass filter helps round out the square waves into more of a sine wave. Then that goes into the non-inverting input of the unity gain amplifier op amp. This op amp has negative feedback through here, so that means the plus input, the non-inverting input, and the inverting input must be equal. And since the non-inverting input must be equal to the output, that means that non-inverting input must be equal to the output. So we use this gain amplifier because no current needs to go into the amplifier, and as much current as we need from the not shown power supply can leave the amplifier, go into the speaker to drive the speaker. This capacitor at the bottom helps smooth out the signal.